Hello, everyone. Welcome to this week's Distinguished Speaker Series from the Center for Data and Computing at the University of Chicago. Our speaker this week is Dr. Deirdre Mulligan from the University of California at Berkeley. And our CDAC director, Nick Feemster, will introduce our speaker and tell you a little bit about the center.
Welcome, everyone. Welcome back to another exciting talk in our CDAC Distinguished Speaker Series on socially responsible AI and machine learning. We're very excited to have this talk today. I'll tell you about that in our speaker in a minute. But for those of you who are new to CDAC, and that may include our distinguished speaker today, I'll say a few words about the center. The Center for Data and Computing at the University of Chicago, CDAC, is the intellectual nexus for data science and machine learning and AI research on campus here at the University of Chicago. Its mission is to bring together researchers from across campus from a variety of disciplines to work on problems of import to society in the area of data science, both furthering the fields of machine learning, statistics, and computing, as well as applications within those disciplines to a broad variety of domains, including the various disciplines that we have all across campus, from the pure sciences to the social sciences. And among our activities, we do some research initiative funding, and which I think illustrates the breadth of the activities and the breadth of our engagement with campus. I think just about every academic unit on campus is involved in CDAC in some form or another, through a seed grant, through some of our other activities, and so forth. So I'll tell you at the end, after our speakers talk today, a little bit about some of the events looking ahead, both to next week, the coming weeks, and also in the summer. But for now, let's turn our attention to today's speaker and today's talk. It's my distinct pleasure and honor to introduce Professor Deirdre Mulligan, who's not only a distinguished colleague, but also a longtime colleague and friend. Professor Mulligan she's a professor in the School of Information at UC Berkeley and a faculty director of the Berkeley Center for Law and Technology. You can read her bio. I'm not going to read it to you because her list of accomplishments would run out the hour. So let me give you a few highlights. Professor Mulligan has a new book called Privacy on the Ground, which is a study of privacy practices in large corporations in collaboration with another colleague at Berkeley Law. She's a member of DARPA's Information Science and Technology Study Group, and a member of the National Academy of Sciences Forum on Cyber Resilience. She is the past chair of the board of directors for the Center for Democracy and Technology, which some of you may know if you're engaged in the tech policy sphere. She is a founding member of the Global Network Initiative, something, if you're familiar with internet censorship, online speech, and so forth, is a very important initiative in that space. It protects and advances freedom of expression and privacy in the ICT sector, and really works against government efforts to censor or repress online speech. Working back further and sort of to bring it full circle, I think to recent times, Professor Mulligan is also a pioneer in the space of electronic voting. She was a member of the NSF-funded Accurate Center back in 2007, which investigated the security, accuracy, reliability, and accessibility of many electronic voting systems, which, of course, we're starting to hear about all again in recent months and years. And so, as you can see, she's a visionary and a pioneer in many areas, ranging from online privacy to voting, to online speech, and we're thrilled to have her. Today, Professor Mulligan is going to speak to us about the role of procurement in policy, and I won't take her thunder away on that because she'll explain it to all of us better than I could. But she's going to focus on the procurement as policy in the area of machine learning and AI. And I'm so excited to hear the talk, and we're just thrilled to have you. So welcome.
Thank you, and I'm happy to be here. I'm going to share my screen and jump into my slides. Give me 1 second. Get that all up and running. Good, you can see them? I'm going to take that as a yes. All right. It's a real pleasure to be here. Thank you, Nick, and the rest of the CDAC folks for inviting me. As Nick mentioned, I'm going to be talking about procurement and its relationship to some of the ethical, social, political implications of machine learning technology. Start, I'm sure some of you would recognize this building. I'll kind of start at the top, the Supreme Court of the United States. And our story starts here because this is where Eric Loomis's legal battle with the state of Wisconsin over a judge's use of a compass risk assessment tool during his sentencing hearing ended. Mr. Loomis had raised two challenges under the Due Process Clause of the Constitution, one challenging the secrecy of the algorithm generally that was being used in his sentencing, and the other challenging the algorithm's use of gender. And I want to focus on that second piece. And there was this question, a dispute between the parties below. Loomis had argued that gender was being used as a criminogenic factor, so a consideration that was kind of independently being used in the model. And the state had contended that gender was being used only for statistical norming or comparing an offender to a group of the same gender for purposes of determining his relative risk. Not completely sure what was meant by some of these terms from the brief, but what was important from my perspective was going up to the Supreme Court, right? This question of how gender is used in a machine learning model, and I should probably caveat, right? Using machine learning, this is like linear regression, right? We're not talking about a fancy model here. This is not deep learning or anything, but it's a useful case study, so I hope you'll bear with me. But how gender is used, right? This isn't like a trivial detail, right? And so the Solicitor General, for those of you who don't know, they're, the government's, the United States government's chief lawyer. And when there's a case that's on appeal to the Supreme Court, right, you get to ask the court to take the case. The Supreme Court doesn't have to take all cases. They have some discretion about what cases they take. And the Solicitor General can weigh in and say, we think you should take a case or don't take a case. And what the Solicitor General's brief in the Loomisb v. Wisconsin case said, I think is really important, right? It says, look, this is a really serious constitutional question about how an actuarial assessment takes account of gender. But this case isn't a suitable vehicle because we can't figure out how this system is accounting for gender. Right. So what's important to me about this, right? This is kind of like as a lawyer, you kind of suck in your breath, right? And so this algorithmic system for determining risk had been incorporated into the system of justice and had gone all the way through the court system in Wisconsin and all the way up to the Supreme Court of the United States without clarifying how gender was used. Surely this is a policy decision, right? This isn't like a mere technical implementation, desiderata. And yet it appears that it wasn't made in a way that kind of reflected its importance from a constitutional perspective, right? And certainly for the perspective of the people who are being judged by the system. Okay. So one might look at this and say, oh, well, maybe this is just an outlier, right? And wow, I can't believe that happened, but I'm sure that isn't the norm. But it turns out, other colleagues and some empirical work, they did a bunch of open records requests seeking information about 6 different algorithmic programs from 42 different agencies in 23 states that were relying on them. And what they found was that governments simply did not have many records concerning the creation and implementation of algorithms that they were using in important systems, right? These are risk recidivism systems. These are child support systems. And they weren't sure, is it because the records are never generated or because the contractor has them? But very importantly, they said there were no records about the model design choices, about the data selection, let alone data cleaning, about how factors were being weighted. There was no indication of validation studies, either the study design or what the results were. And at a really basic level, they found that most governments didn't even have records of what problems the models were supposed to address and what the metrics of success were. And more recently, there's a study that was commissioned by the Administrative Conference of the United States, which is an advisory board, an advisory agency for federal agencies. Colleagues at Stanford looked at how federal agencies were adopting machine learning systems, and they found that there was insufficient publicly available technical documentation to determine what methods are deployed. Their descriptions appears more like, marketing language, right? And so the absence of technical details to actually understand what are the important choices embedded in these models that are related to policy issues isn't just a quirk of the Loomisb case, but seems to be common. So, what sorts of issues are kind of policy issues that are embedded in models? Well, we can think about how we operationalize the target variable, right? So when we're thinking about the development of the risk recidivism tools, which are the ones that have been kind of, I think, receiving the most scrutiny, is rearrest a really good proxy for risk of recidivism? Well, we know that it's a confounding, factor, that it's not just a product of whether or not somebody committed a crime, but it's also a product of policing practices, right? And if you're in a community where there are more police presence, or if you are a person who has less access to private places, and so you might spend more time in public places, right, that the extent to which you are caught when you engage in a second crime is going to be different than somebody in another context, right? So how we operationalize the target variable, what we're predicting, right, really matters. And that's a policy choice, right? The choice of the model. So you got to choose your modeling framework, right? The framework that you use to develop the ultimate model that you use in your system. And that framework, your modeling choice embeds a theory of how or why a phenomena is occurring in the world. And so this is a particular example of PredPol, a predictive policing system that has been adopted off the shelf and without public process by law enforcement agencies around the country. It uses a seismological model to describe how crimes propagate throughout a region. And now, the motivation for using a seismological model, I guess, is a belief that an original crime has a ripple effect that leads to other crimes, like an earthquake, right, leads to aftershocks and propagates through space and time. It's not really clear to me how that relates to any particular theories of crime, right? I understand how that relates to our understanding of how earthquakes propagate. But, regardless of whether or not you think there's a good reason for adopting this particular model, it's a policy choice, right? The decision about our theories of how things happen, those are our policy. Thresholds. You may remember Amazon's facial recognition technology has come under some scrutiny. And out of the box, it has a default to 80%, right? That's the threshold of performance. And that doesn't have any particular relation or relevance to the domains in which it's being used. In their material, if you go down, I don't remember what page it was on, but very deep down, there was a suggestion in their 433-page system documentation that if you were using it in a law enforcement context, you should use a threshold of 99%. The out-of-the-box default was 80. And, the question of, your tolerance for false positives and false negatives is going to vary depending upon the application space. And again, is a policy choice, right? It's not just a mere implementation issue. And then finally, one of the issues also that came up with Amazon facial recognition has come up with facial recognition generally, was the questions about training data. And when we think about the data that a model is trained on and the ways in which that's going to generate future failures and future successes and distribute them differently across different populations, again, this is a technical choice, but with enormous political implications. So, question for me becomes like, why are these systems being adopted without adequate attention to all of the policies that are embedded in their technical design? And it seems that the fact that they're being viewed as procurement, right? So through the lens of, we have a policy within our agency, and what we need to do is just we're going to, instead of doing it through pen and paper, we're just going to adopt a technical system to implement it. And when administrative agencies, regulatory agencies, when we think about the procurement process, there are particular concerns that we have about government action, right? We're concerned about the fairness of the bidding. We're concerned about the public getting kind of adequate bang for their buck, right? So cost effectiveness. We're concerned about transparency, right? We might want to know what the government is buying to do what work. We're certainly interested in innovation and competition. We're interested in making sure there's no cronyism. But those are pretty different objectives that come up when we're thinking about policymaking, right? And there we have the Administrative Procedures Act, which comes into play when we understand that agencies are given responsibility for taking a legislative act by Congress and bringing it through a rulemaking process into a set of rules that are going to govern regulated stakeholders, or if we want to think they're going to be using it to distribute funds or whatever it is that the government is doing. And there, certainly, we're concerned about some of the transparency issues, but we're also concerned about efficiency and effectiveness and fairness and issues that go to democratic legitimacy, in particular transparency, public participation, relevant expertise, and reasoned deliberation. So because government agencies seem to be procuring many of these systems, at least at the state level, that seems to be the normal way in which they're going about coming to use algorithmic systems, machine learning systems. There's an absence of democratic process, because there's little to no agency or outside expertise beyond the vendor being brought to bear on the process. The procurement process isn't one where we envision public participation, right? It's a relationship between the government and a vendor. There is very little need for the agency to explain itself beyond kind of, did you let a contract to somebody who made a reasonable bid, right? Did we get a good bang for our buck? And there's not the same development of a factual record of how the government goes about its decision-making. So in contrast, in administrative law, when we think about policymaking, right, the key benchmark is this limitation that government decisions cannot be arbitrary and capricious, right, which gives agencies a high degree of latitude, right, to figure out exactly how to implement the law that that the legislature has passed down. However, that that process has to be a product of contemporaneous, reasoned decision-making. They have to bring appropriate technical expertise into the process. There has to be an adequate level of decisional visibility, right? How they made the decision. And so you can look at the notice and comment rulemaking process is kind of the easiest place to see this, where the government says, here's the rule we're going to adopt. There's a process by which any person who wants to participate and critique and comment on that rule can do so. The government has to take account of the comments that have been received. They have to address them. The decisions they make have to be based on kind of scientific evidence to the extent it's available. They have to address meaningful objections that have been received, et cetera. And so at the very least, right, it requires a record of what issues were ventilated, why the agency chose the path they did, a reasoned analysis about relevant factors, and importantly, it also can't consider irrelevant factors, right? Or they can't decide without sufficient evidence. So an agency is going to fall short in particular where they have no record of having examined relevant data, or there's no explanation for their actions that connects the facts, the expertise, and the decision that was yielded. And if we go back to the Bronis and Goodman's findings, right, where we have this conclusion that prediction models seem to be being built and used without key policy decisions ever having been articulated, let alone justified or recorded, this would seem to be exactly the sort of thing that the arbitrary and capricious standard is aimed at making sure doesn't happen, right? So one of the problems I think we face is algorithms are kind of increasingly everywhere, and machine learning systems are going to be increasingly everywhere. And so I don't want to suggest that every time an agency is using a technical system or using an algorithm, that it needs to be considered akin to the adoption of a substantive rule as part of administrative law. But I do want to suggest that the way in which we think of technical systems and consider whether or not what they're doing is kind of implementation or is something more akin, at least in part, to policymaking, we can be guided by existing precedents in administrative law. And we can be guided in kind of two ways. So one is where an algorithmic system, for example, is going to limit future agency discretion in deciding an issue that is of legal consequence to the public, right? That's an area where we need to be paying deep attention to some of the policies that are embedded in that algorithmic system in its design. And where there are normative choices that are going to be dealt with during implementation. And I'm going to kind of talk a little bit more about what those are, although I've kind of highlighted some of them at the front of the talk. So what does it mean to limit future discretion in areas of consequence? So I'll give you, one example that I think is kind of an easy one to think about, given that we were just talking about risk assessment models. This PICUS v. the United States Board of Parole was about the development of guidelines, right? And they had one set of guidelines that had some general categories and factors and subcategories. And then there was a secondary set of guidelines that were developed. And what the court said was, look, these are substantive agency action, that these are, substantive rules, because they're going to limit and constrain the ways in which the agency makes decisions about people's parole, the ability of people to gain parole, right? And so I think we can look at this in light of, at the state level, we've already seen some courts that have looked at the adoption of algorithms in the context of, for example, benefit systems. And they said, that's the equivalent of adopting a new policy for how you are determining benefits. It's about substantive rights or interests of the public, and it is being used basically to embed a new model of decision making. The second is where there might be normative choices in the implementation, right, that are going to be kind of design elements in the algorithm. And here I'll give you like another particular example. In Hochter v. U.S. Department of Agriculture, what happened was the Department of Agriculture was making a decision about how to implement the requirement that there were adequate containment for dangerous animals. And they had had a fence height of 9 feet, and they had kind of gone back and decided they wanted to, or I think it was 7 feet, and they were raising it to 8 feet. And what the court said is like, look, this is not an implementation detail that's driven by the law, right? It's not driven by legislation. That this question about whether a 6 foot high fence or an 8 foot high fence or a 9 foot high fence, this is a policy choice. It's not driven specifically from the law. The law didn't say, this is how high the fence should be. And so in a very particular way, that means it's arbitrary, and therefore it needs to be subject to expertise. It needs to have like a reasoned basis, and we need to have public participation around that normative choice. They also went on to flag the fact that numbers are likely to be arbitrary in that particular sense in a lot of ways, right? That there is no particular number that is a unique candidate, uniquely aligned with whatever the legislative directive was, that it is always going to embed some kind of cost-benefit analysis or other sort of policy determination in selecting that number. So what might this mean for machine learning when we look at it through the lens of administrative law? Well, there's a bunch of other cases that I think are useful to just kind of flag. There are cases looking at the policy implications of decisions to, err in the direction of false negatives or false positives. Or decisions that have said, look, you need to justify the assumptions behind the use of a model, right? You can't just choose one. You need to justify the methodology behind models used for risk prediction in particular. You need to take steps to confirm the validity of chosen models. You can't just wish that they're going to perform in a particular way. And that you have to provide information about the source of the data that was used to develop the ultimate model. So I think it draws our attention to the fact that there are normative choices that administrative law currently recognizes as policy choices. And if we are going to be adopting machine learning systems that are going to be used to make decisions about the public, that the kind of risk of arbitrary and capricious challenges require agencies to take certain steps that bring adequate expertise and research in to inform those choices, and do some work to make sure that those policy choices receive adequate public deliberation and input. So key questions to ask are, is this machine learning system going to be constraining future agency discretion in an area of legal consequence for the public, right? So it's outward looking rather than inward looking. And 2, does it embed normative choices of implementation that aren't dictated by law? And I want to say, there's a big difference here, I think, between an expert system and a machine learning system, right? In an expert system, we can imagine there's a detailed policy that might have been adopted through perhaps a notice and comment process as part of administrative procedure. And then the question of translating that into an expert system, right? One could imagine that would be viewed as implementation as long as it was kind of adequately overseen. But when we think about machine learning systems, right, we're kind of often, they're trained on data that is the output of prior expert decisions. They're not developed with a decision tree, right? It's a totally different way of thinking about implementation. And so for that reason, I think these questions about policy are much more likely to arise when we're thinking about machine learning systems, and be more difficult to kind of think through than they are if we were thinking about, for example, the adoption of an expert system. Okay, so if we go back and we think about that risk recidivism system that Eric Loomis was subject to during the sentencing phase, what sorts of questions might this suggest we need to be considering as policy? So the definition of recidivism, right? It turns out that different risk recidivism systems use different methods and they use different predictors. What data is used for training? What's the source? How representative is it? What biases might it include? Should a group be subject to a different cutoff, right? In the context of the Loomis case, right, Wisconsin was arguing, well, we're using different models, right, or tweaked models or different cutoffs for men and women. Is there a good justification for that? Or are there other classifications or categories that are to be subject to different sorts of line drawing? That's a policy decision. What is local? Often I'll hear machine learning folks talk about, oh, well, you would never use a model trained at that hospital, at this hospital. They're like, you need to localize it. And they'll say that in a way that suggests that I should somehow or other understand what is local and what isn't. And of course, where we draw the lines around whether or not a model is kind of adequately tuned for the population that it's going to be applied to, that too is a political question, right? What steps have been taken to validate whether or not that localization is appropriate? These questions about how risk is communicated. Are you communicating risk in actual statistical risk or risk labeling? Are you kind of binning information? Who draws the lines, right? If we're thinking about a risk recidivism tool that's saying high, medium, and low, who drew the lines about high, medium, and low? What does high, medium, and low mean? And how is that communicated to the user of the tool? And how do users interact with the tools? That sometimes a machine learning system, the way in which it's put into an agency process is going to have real implications for the remaining discretion of agency staff. And it may not just be about the tool design, right? It may be whether or not, if you decide to override the tool, do you need to write a memo, or are you allowed to basically decide whether or not the result coming out of the technical system is something that you should defer to or not? Does one require an explanation and one not, right? The different relationships between the new tool and the requirements of the human ultimate decision maker may really influence the extent to which we think this is a kind of decision support tool or something that is really constraining the substantive discretion that remains for agency staff. So what are some of the goals that I think should guide the development of the use and adoption of machine learning systems if we are interested in satisfying what we refer to as the technocratic and democratic concerns? Well, do we have adequate expert input? Do we have public participation? And do we have robust deliberation about the choices that are reflected in the system? I think the question of bringing expertise in at the design phase, really needs to cover everything from what to optimize for, how to operationalize the goal into a target variable, the modeling frameworks that are used, not just the data selection, but the curation, the cleaning, decisions about the use and inclusion of data about protected traits, an area that is receiving more and more attention, The use of precise numerical limits, such as cutoffs and thresholds, particularly those that cabin discretion, right? So if agency staff, for example, are going to have to defer, or if their decision not to rely on it is viewed as kind of an anomaly or a secondary process. And in general, the interaction between agency staff and outputs, in part because of concerns with things like human deference, right, automation bias to technical systems. So one question is like, how do we facilitate expert input? And I think these become, really important concerns. And often people see expert input and they assume that what I mean is how do we get the input of experts in machine learning? And in fact, often these systems fail because we haven't done enough to solicit expert of the domain experts. And I think some of the work that's important for researchers to be thinking about, as well as practitioners, is how we create boundary objects. And that could be vocabularies to talk about, for example, fairness, right? What kinds of fairness might we be aiming for here? That help domain experts and machine learning experts talk across and with each other. I think that we might need some central hubs of expertise within the federal government that help government agencies across the government understand what are the key questions that they need to be asking when they're thinking about using a machine learning system, right? So to go back to like these sorts of questions, saying here are the sorts of questions, here are the ways in which we need to be thinking about these systems. And then the question I think that becomes even more complicated is how do we facilitate public participation, right? We've seen historically, right, we think a lot about impact assessments. Those are a familiar tool of government agencies, and they're a familiar tool in the area of privacy, right, where we have privacy impact assessments. But we've seen a lot of developments from the research community, some coming out of industry as well, around model cards and data sheets that try to help surface some of the important decisions that are embedded in machine learning models. I don't think any of those are quite at the state where they're rich enough or useful enough to think about them being meaningful tools for the public to participate. Other models that I think are interesting to think about are advisory committees, simulations. One of the things that I found in looking at the ways in which folks who are trying to develop differentially private approaches to working with data within industry, when they were trying to talk with their colleagues who were responsible for privacy, it wasn't enough for them to explain the system and explain, the way in which it had modeled privacy. What they really needed to do is provide them with some simulation that allowed them to explore and understand, because that was the only way they could get non-experts to understand the way in which the system was protecting privacy. And then I think there are some real particular challenge that we have with machine learning, particularly if we're thinking about using models that are open rather than closed. The question of kind of like when we assess them and how we assess them becomes even more important, because these are interventions, right? And humans are, of course, going to behave strategically at times to engage with them. And so the need for kind of iterative thoughts about assessment really matters. And then finally, because these systems embed policy, I think it's really important to think about the ways in which the technical systems themselves can make those policy choices visible in an ongoing way to the people who are using the systems. And so, in the beginning of the talk, I talked about like the Amazon 80% threshold set as a default, right? And I think when we're thinking about the use of a system, it's important where some of those design choices continue to be surfaced to the people who are relying on them. So they serve as like moments of critical reflection, like, oh, is that the correct setting, or has the policy environment changed and we might need to shift that setting? Or is it time for our system to be retrained on new data because we have experienced real shifts in the population, right? And so ways in which we make sure that some of the normative choices that are embedded in these systems maintain their visibility in use are really essential if we want people to make sure that we revisit those policy choices. And this is joint work with my colleague Ken Bamberger at Berkeley Law School. And I also reference some joint work with some others around this thing called fairness, which is one of these boundary tools. And with that, I will turn off my screen share and open it up for questions.
Thank you so much, Dr. Mulligan. That was a great talk. I will read questions that are asked from people in the chat. So if you're watching via YouTube or Zoom, please do drop your questions in there and I'll pass them along. So I'll start with a question. As you probably know, explainable machine learning or explainable AI is kind of a buzzword right now in the field, but explainability is a very vague concept. So are there ways that these legal standards could perhaps help computer scientists working on these models define a standard of explainability that would make them sufficient for these policy uses?
Sure. So I think one of the things that legal scholars have teased out, not only legal scholars, but to some extent legal scholars, like explainable to whom and like what needs to be explained. And I think, initially people are like, oh, we need to explain the decision, right? And surely, somebody who is subject to a particular consequence because of a machine learning system, they need to understand why the decision was reached, right? So like the explanation of the outcome. But if we're interested in, for example, responsible or trustworthy machine learning systems more generally, we might be really interested in making sure that people understand not just what was the model that was chosen, but what are the assumptions behind it, right? Because often the problem with the system, right, may be the assumptions on which that informed the development of the model. And so I think when we're thinking about kind of different parties as well as kind of different needs, the explainability of what really matters. Hopefully that's a partial answer.
Sorry, I was on mute. Thank you for that. A question from the YouTube chat. Is there a set of principles to tell us in which situations gender arrays should or should not be used in a machine learning model? Because in some domains, such as music recommendation, it is used as a feature. Yeah. So the law is not going to speak to the use of machine learning at this point in a music recommendation system per se. So one of the important issues that I think is really coming up is in the context of areas where we do have equal protection laws, right, that are guideposts. And, historically, people have thought about, well, we can't use race or gender as part of a model, right? But of course, for those of you who design systems, I think quickly understand that to the extent that those things are important, right, that if people talk about race being redundantly encoded, and given that race is a social construct, and I don't mean that it isn't a real thing that has real impact in the world, I mean that to say that it has been socially constructed throughout time in different ways, right? And what is redundantly encoded, like that is race, right? And so if you actually want to protect or against disparate impacts, you can't just make the system blind, right, to those impacts, that you actually need to use that data to help you develop a system that both
doesn't take race or gender into account in a way that would be problematic, but also isn't blind to the impacts that the system might have along race or gender lines. There are some, complications about exactly how you do this and how they align with kind of guidance from regulatory agencies. And I think it's an area of kind of active work. There's a nice piece, I think it's Karen Levy and Salam Barocas, and they have a few other co-authors on the interaction between kind of like model tuning and existing EEOC guidance in the US that I think is really important to look at. And it's interesting because it looks at kind of, are you tuning or are you correcting? And the ways in which you approach these issues might have very different legal consequences.
Thank you. A question from Blazer. He says, thanks for a great talk as always. You mentioned that tools like model cards and data sheets aren't yet sufficiently rich for supporting public engagement with automated tools and models. What are some of the directions that you think would help tools like these become sufficient for public engagement?
Yeah. So I think there's a few different ways that we could think about going. And, when I say they're not rich enough, it's not like they are quite rich, right? And in some ways they're like too rich for the public, right? Like you can provide the public with lots of information, but if they don't have the expertise to make sense of it, it isn't necessarily meaningful. And so, some of the ways that I think we've dealt with the need for technical expertise to help foster public participation or community participation, right? They vary. And so I'll give you one model. In the context of environmental cleanups, right, where you might have the affected community and you have the industry that, led to pollution. One of the things that can happen is that the community can actually have their own expert provisioned, right? So that they have adequate independent technical expertise to help them understand like various alternative courses of remediation. And one of the things that I think was interesting in looking at the ways in which some of the states or counties that were using risk recidivism tools, some of them worked with academic experts and had them kind of generate kind of impact assessments of different model choices that could then serve as the basis for public conversation. If we look at New York, they created this algorithmic impact, their algorithm task force, right? Which is a group that I think was supposed to, if the whole thing had functioned appropriately, was going to help the public understand what was at stake. Because if we just look at the model cards or we look at the data sheets, right, the average citizen or even the average advocate on behalf of the homeless, right, might not understand the implications for those model design choices or the data selection or cleaning choices. And so I think one of the ways that we can help that is figuring out different ways to inject experts that are not, for example, the vendor's experts or even the agency's experts, that can be basically providing some translation or some, boundary objects that help surface issues at the level that the public can engage with them, right? They're not going to tell you what model to choose, but they might be able to give you good feedback about what are the strengths and limitations of two different models if some experts help them understand what the consequences might be of the adoption of those two models.
Excellent. A question from Christopher Grazul. He says, how might we address potential conflicts of interest where users must rely on vendor expertise to understand the technical or normative decisions embedded in a tool?
Yeah. Ideally, I would like to be in a world where the public and governments don't have to kind of solely rely on vendor assessment. And, part of that may be like, we need new benchmarking capacity and new measurement approaches at NIST, right? That might give us new ways to kind of test models. I think we probably need additional ways to think about external validation. And right, so the obviously, vendors are always going to bring expertise to the table, and we want that to be so. But I think that we also need ways to make sure that government agencies and the public are not solely relying on their expert judgment. And so whether that's new assessment and validation techniques or greater expertise in the public service, right? And so I think that we are going to have an increased need for technical expertise, even in agencies that historically might not have had a lot of computer scientists, for example, on staff. And we've seen a shift in that, over time, that, you can look at an agency like the Federal Trade Commission that had no chief technologist years ago, and they didn't have a shop that had lots of technical people helping them understand technical systems. But as they were overseeing and bringing enforcement actions that required them to understand technology, they had to invest in those resources. And I think it's clear that government agencies are going to need more technical resources. And I think one of the tricky questions to ask is how much of that is going to be on kind of an agency by agency basis, or how much can we provide some centralized expertise, such as the U.S. Digital Services or 18F, right? Can they be used as kind of a more central source of expertise that can be kind of let out or used by different agencies when they're facing a particular decision about a system, right? Where they might not need that technical expertise on board all the time, but they need it in a kind of bespoke way.
Great. Lots of questions coming in. I have time for one more before I send it back to Nick. This comes from Galen Harrison, who asks, on your point about making decisions contestable, many of the domains that you could imagine these decisions touching take place in a nexus between expertise and values, quote unquote. I'm curious how you see balancing the need to, quote unquote, trust science while also making decisions contestable. For example, suppose the EPA has a model to do with climate change. How do you balance making that model contestable while also preventing openings for bad faith criticisms?
Sure. So when I'm talking about contestable design, I'm thinking about the climate scientist, right, who's using the system in a government agency at NOAA or right at the EPA. And contestability for me, right, as a system design property would mean that they're able to kind of explore the model that they're using to do a simulation, for example. I think that, the government now today, right, when they're adopting a substantive rule, they have to be open to all sorts of arguments, right? But that happens at the time of like adoption of the system. And the contestability that I'm talking about is more a kind of runtime. So I just want to make sure I'm like separating those two things out. Federal agencies are very used to dealing with fact-based and science-based arguments and other sorts of arguments. And I'm pretty confident that they can continue to do that, even when the thing that they might be looking at is a technical system. But there's always going to be people who are making, to use your words, quote unquote, bad faith arguments, right?
Thank you. I will now send it to Nick for one last question and to take us home for the day.
Thanks, Rob. And thanks, Deirdre, for joining us today. It's a really informative talk. I think really important for people, particularly in the computer science space, to hear everything you had to say. So thank you so much for the talk. I guess since I have the privilege of the last question, and today's talk, of course, was on machine learning, but you're also an expert in privacy. And so maybe I'll use this as an opportunity to touch on your other expertise. Sure. I was wondering sort of, you talked about some really important considerations like choosing thresholds, choosing things to optimize for, choosing the appropriateness of model. But another one that strikes me, and I think, you're well familiar with too, is the need to gather certain data in the first place. So over collection, of course, is a real risk. And so is there anything, in your work or in the conventional wisdom or in sort of administrative norms or law that speaks yet to that, things that might say, hey, you don't actually need to collect all of that stuff. Your system would be just as effective with a much more minimal approach, either through anonymization or aggregation or sampling, or much less data than just dragnetting everything. I'm wondering what's going on in that area, and if you have thoughts.
Yeah, that's a good question. So, the privacy impact assessments, so the federal government, federal agencies are required to do a privacy impact assessment where they're either making a decision to collect new data or a technical system is going to be interacting with data in a new way. And that's certainly an opportunity to raise questions about overcollection. And, you do see that if you look at some of the privacy impact assessments that have been done by the privacy officers of federal agencies, they can, raise questions about the potential overcollection of information. At a more systematic level, I think, the use of machine learning systems is driving, I think an increased interest in maintaining as much data as possible, right? Because there's always the hope that with a larger data set, we can learn even more. And so in part, I think some of the work by computer scientists to explain why large models might not always be necessary or better, or more data might not always be better. You might want representative rather than quantity and quality are not always the same thing. So I think one of the things that the computer science community can potentially lend to the game is a better understanding of where more data is in fact better, and where other aspects of the data rather than just quantity might be what is really needed. Great,
thanks. That's excellent food for thought for how I think some of us in computer science can engage with many of the things that you talked about. So hopefully this is the start of more discussions between computer science, data science, machine learning, and experts such as yourself. Thank you so much for joining us today. It was an honor to host you. I learned a lot from the talk, and we hope we have a chance to welcome you in person in the future. And to close out today, I'll remind folks that Professor Mulligan is but one in a series of really exciting and phenomenal talks that we've had this winter. Sadly, we're coming to the end. In 2 weeks, we will have Kate Crawford, who will join us. Just as a reminder for folks, it's going to be, for those of you in Chicago, it'll be an evening talk. I believe it's at 5 or 6 p.m. Central Time. I think it's at 5 p.m. 5 p.m. Central Time. I think it's breakfast time for Kate. I think she's beaming in from halfway across the world. So we'll be very fortunate to welcome her in 2 weeks' time. And I think that'll be a great way to close out the series. I think Kate, just as a preface to that, I think hearing Kate speak at NeurIPS a couple of years ago was really eye-opening for me, just to sort of understand what this whole area that we've been talking about for the last quarter is really all about. And so I think I'm really eager to hear what she has to say about the past, present, and future, because she's really opened, I think, a lot of our eyes to this topic. So we've got a little hiatus, right? We have 2 weeks until Kate, but then on March 11th, I'll remind folks that we have another exciting installment in our other series, which is the Data and Technology Outlook series. That's a conversation of folks with industry. We've just started to kick that off. We have a few more coming, but our imminent talk is going to be with Ranveer Chandra, Chief Scientist at Microsoft Azure Global, and Supratik Guha, who's here in PME, talking about AI for agriculture and food systems. And yeah, that's going to be very exciting. I think for many of us that'll be a completely new topic. But I'm also personally interested in that because Ranveer is also an expert in computer networking, and so it'll be very interesting to see how he's pivoted into this space. If you like today's talk, if you like the content, you can watch it again on the YouTube channel. You can also find us in various other places in the internet, as you can see here. We're also in a number, the usual places, but we're also on GitHub. And that I think is a preface to some of our ongoing work, trying to develop open source tools and pipelines in this particular area. And I think you'll be hearing more and more about that moving forward. Okay, so I think without further ado, I will thank Deirdre once again. It was a pleasure having you. Thank you so much.
And thank you.
And we'll see everybody again on the screen soon. Have a great day, everyone.